To determine the forces in the truss members by using method of joints, first of all let us see if it is a perfect truss, if it's stable. So it should satisfy the relation M is equal to 2j minus R. The number of members are 1, 2, 3, 4, 5, 6, 7, 8, 9. So M is equal to 9. Number of joints are 1, 2, 3, 4, 5 and 6. So J is equal to 6. And the number of reactions are, at A there will be two reactions, VA and HA. And at B there will be just one reaction, which is RB. So R is equal to 3. Since if we substitute, 9 is equal to 2 into 6, 12 minus 3, 9. So hence we have a stable truss, or it's a perfect truss. To calculate the reactions, let us consider the moment about A is 0. So if we have, for the truss to be stable, summation of the moments about A is equal to 0. So the moments about A would be due to the 6 kilonewton force, which is clockwise, 9 kilonewtons is clockwise, and it's balanced by RB, which is going to be anti-clockwise. 6 is at a distance of 2 meters, this is at 4 meters, and RB is at 4 plus 4, 8 meters. So we have 8 RB is equal to 6 into 2 plus 9 kilonewtons into 6 meters. So we get RB as 8.25 kilonewtons upwards. Now considering the summation of the vertical forces to be 0, the vertical forces are downwards are 6 and 9 and upwards are VA and the reaction at B is equal to 6 plus 9. So from here we get VA is 6.75 kilonewtons upwards. Considering the horizontal forces is 0, there are no external horizontal forces. So the reaction, horizontal reaction at A is 0. Now to determine the forces in individual members, let's consider joint A. So at A we'll assume that the forces are in tension. So it's being pulled. So A is pulling the member AC, is stretching the member AC. So C will in turn pull the joint A upwards when it is in tension. Similarly the case with AE. And the reaction VA is already known, HA is 0. So VA is known to be 6.75. So if I have this angle, if it is called as theta, I know in this triangle I have, this is side 3 and 2 in my AEC, and this is my angle theta. So as per Pythagoras, this would be root of 9 plus 4, 13. So I have my cos theta is adjacent upon hypotenuse, which is 2 upon root 13, and sin theta is opposite upon hypotenuse, 3 upon root 13. So at joint A, the vertical forces are balanced. So I have summation vertical forces is 0 as per conditions of equilibrium. So my AC sin theta equal to VA. VA is upwards, so AC has to be downwards to balance it. So I have my AC is equal to VA upon sin theta, 6.75 upon sin theta, or into root 13 upon 3. So I have this is AC is 8.1125 kilonewtons. This will be in compression, because AC is going to be like this. Instead of tension, it will be compression. My AE, so AC is pointed to the downwards to the left. So AE will be to the right, which is fine. So it is in tension. AE is equal to AC cos theta. So I substituting cos theta as 2 upon root 13. I get this is 4.5 kilonewtons, and it is in tension. So AE is to the right. So it will balance the component of AC which goes to the left. After A, we'll come to E. So at E, the forces are 6 kilonewtons downwards, AE, which was in tension. So at A, the member AE is pulling it to the right, pulling A to the right. That means joint A is pulling AE, is stretching AE. So joint E will be stretching AE to the right. So AE will be pulling joint E to the left. Action reaction, equal and opposite. So in this case, we can clearly see that CE will be 6 kilonewtons. So it is upwards. So it will be in tension as shown. And EF will be equal to AE, which is 4.5 kilonewtons. Since it's to the right, it's again tension. Let's come to joint C. So at C, the forces are AC. We know it's compression. So at point C, it will be acting towards the joint. So this is AC. CE was in tension. So it is away from the joint. So this is my CE. Both are known. What is not known is CD. We'll assume it is in tension. And CF. We'll assume it is in tension. Since I know AC and CE, only CF has got a vertical component. CE does not have a vertical component. So let me consider the vertical components first. Summation Fy equal to 0. So this theta is, for the triangle ACE, it is 3, 2, root 13, or it is tan inverse of 2 upon 3, which works out to 33.69 degrees. Similarly, let me call this as alpha. So for alpha, for this triangle, it is 3, 4. So this is going to be 5. So alpha would be tan inverse of 4 upon 3, which is 53.13. So let me write it over here itself. This is 53.13 degrees. So considering the vertical forces, I'll take this on the next page. Considering the vertical forces is 0, the vertical forces are due to CE, which we found out as 6 kilonewtons, AC cos theta, and CF cos alpha. So I have AC cos theta is directed upward. So we'll take it as positive. The component, upward component is, vertical component is upwards. So I have AC cos theta, 6 kilonewtons is downwards, minus 6, and CF, the vertical component will be cos. So minus CF cos alpha equal to 0. I know AC is 8.1125. I know theta. I know alpha. So I'll get the value of CF as 1.25 kilonewtons. So CF, what we assumed it is downwards is correct. So that is tensile. To calculate CD, let us consider the horizontal forces is 0 for the condition of equilibrium. Let me write horizontal, and this was vertical. Horizontal forces is 0. So the horizontal forces are CD is to the right, so I'll take it as positive. Now my horizontal component of CF is CF sine alpha. CF sine alpha, and 6 kilonewtons does not have any horizontal component, but AC has got an horizontal component, which is AC sine theta. Again, that is to the right, so I get AC sine theta equal to 0. So I know the value of CF. I have just found out. I know alpha, AC is known, theta is known, so I'll get CD as minus 5.5 kilonewtons. It is negative, that means the direction that we have assumed is in the reverse direction. So we had assumed it is to the right, so it's negative of that, which means it is to the left, which means member CD is under compression. After C, then we can go to D. So at D we have CD. CD is in compression, so the force acts towards D. And there is DF. Let's assume it is tensile. And there is DB. So I know DB, to balance the horizontal components, I should have taken it as tensile, but I know it will be compressive because it has to be pointing towards the left as CD is towards the right. So if this is theta in the triangle DFB, I know this is 2 and 3. So it is tan inverse of 2 upon 3. So I know my dB sin theta, the opposite side is dB sin theta is CD, which is 5.5 kilonewtons. So I get dB equal to 9.9153 kilonewtons compressive, because it's towards the junction D. My DF will be dB cos theta. It's pointed downwards, so it is tensile, it's correct. So that's works out to, so cos theta is 3 upon root 13. So I get this as 8.25 kilonewtons, and it's away from the joint D, so it is tensile. After D we can come to F. So at F the forces are, there is a 9 kilonewton force downwards. We'll assume BF is tensile, it's to the right. DF is known, DF is compressive. Sorry, DF is tensile, so at D it is away from the joint D, and we know it is 8.25. And EF, again I know it is tensile, so it is away from F. This is F, not D. Away from F. So that value we had calculated to be 4.5 kilonewtons, and there is a member CF, and CF we had calculated it to be tensile, so again at F it is away from, and CF the value was 1.25. So to verify the vertical forces are due to CF, DF and this 9 kilonewtons. So we can verify if the summation of the forces, because these three are known. So we can verify if the vertical forces are balancing each other or not. Whether 9 kilonewtons is being balanced by the vertical component of 1.25 and 8.25. So for this angle theta, we have, this is 3, 4 and 5. The vertical would be, the sin theta would be 3 upon 5 or 0.6. So to find out, upward forces are CF sin theta plus 8.25, which is CF into 0.6, 1.25 into 3 upon 5 plus 8.25. So this works out to be 9 kilonewtons upwards, and the downward forces 9 kilonewtons downwards. Therefore, summation of the vertical forces is 0. So whatever we have calculated till now, it is just a confirmation of this. To calculate BF, we will consider the horizontal forces. So since horizontal forces is 0, we have BF is being balanced by EF and the component of CF, horizontal component of CF. So BF is equal to EF plus CF cos theta. Cos theta is adjacent upon hypotenuse, 4 upon 5, which is 0.8. If we substitute the values, we get BF is equal to 5.5 kilonewtons tensile. So we have calculated BF also. Then lastly we come to joint B. At joint B, we have the vertical reaction at B is known to be 8.25 kilonewtons upwards. For DB, we had already calculated it is compressive, so it is downwards. This is DB, and the value was 9.9153. And BF, we had calculated it was tensile, so it is to the right, which is 5.5 kilonewtons. So we have calculated the forces in all the members. So this we are just confirming whether our calculations are correct or not. So this theta would be 3, 2 and root 13. So tan inverse of 3 upon 2. So to confirm, we have the dB cos theta is being balanced by BF. So my dB cos theta, which is 9.9153 into cos theta being 2 upon root 13. So that is working out to be 5.5 kilonewtons, which is your BF. So the horizontal forces are balanced and the vertical forces is 8.25 kilonewton upward is being balanced by the vertical component of dB, which is downwards. So dB sin theta, which is 9.9153 into 3 upon root 13. So if we calculate this, we get it as 8.25 kilonewtons, which is equal to your reaction at B. So even this is balanced. So all our calculations are correct.